Today's video is on 3.6, which is solving systems of equations with three variables. If you struggle with solving systems with two variables, go back, watch your 3.2 video again before you watch this one, because if you can't do it with two variables, it's going to make it really hard to do with three variables. There are three steps in which you want to use in order to solve the equation in three variables using systems. The first thing you want to do is find a variable that is easy to eliminate. If you look through your book, it'll say that you can do it with substitution or elimination, but I suggest using elimination. It's much easier than substitution. That is easy to eliminate. What you want to do once you do that is you're going to write that equation twice. Alright, so when we look back, we've got 3, 2, 4, 2, 1, 3, 5, 3. So the easiest variable here to solve for is y. That means that we are going to use that equation 2 times. You always want to look for a coefficient of a positive or negative 1 because that's going to be the easiest one that you're going to be able to cancel out. So we're going to write that second equation, 2x minus y plus 3z, 2 times 2x minus y plus 3z is equal to 4. Now your second step is to write each of the other equations with the equation from number 1. Write each of the other equations with step 1. Okay, so we're going to take our 3x plus 2y plus 4z is equal to 11, and we will take 5x minus 3y plus 5z is equal to a negative 1. When we chose y in the first step, we're going to eliminate y. When you choose that variable, that's the variable that you're choosing for the rest of the steps. So your last step, step 3, is use elimination. Again, you can use substitution, but elimination is the easiest. To eliminate the variable you chose in step 1. Okay. So when we look at the first one, we chose a y, and we have a 2y here. So to get the opposites to cancel, we would multiply the top row by 2. That gives us 4x minus 2y plus 6z is equal to 8. We did not change the second equation, so we just copy the rest of that down. Our y's have been eliminated, so that allows us to have 7x, a 10z is equal to 19. We're done with that one for right now. We're going to move on to the second equation we set up. We have a negative 1 and a negative 3y. We want to make that top a positive 3y, so we multiply the entire top equation by a negative 3. That gives us a negative 6x, a positive 3y, a negative 9z equals a negative 12. We did not change the second equation, so we go ahead and just copy that down. When we look at that setup, our y's have canceled. A negative 6 and a positive 5 gives us a negative x. A negative 9 and a positive 5 gives us a negative 4z is equal to a negative 13. What we just did is we eliminated our y variables, and what we're left with are two equations with two variables. The reason why we want to choose the same variable each time is we've got x's and z's, x's and z's. If we had eliminated different variables, you wouldn't have done yourself any favors because you would have had an x and z here and maybe an x and a y there. You want to make sure that when you end up with your two equations, they had the same two variables left. So we carry that equation down, 7x plus 10z is equal to 19. Carry this equation down, a negative x minus 4z is equal to a negative 13. Once you have an actual system with two variables, you're going to solve the way you would solve any other system of equations. Again, you could use elimination or substitution. I would use elimination here. And I have a positive 7. I'm going to make this a negative 7. So I'm going to multiply the second row by a 7. The first equation is not changing, so I'm going to recopy that down. We've got a negative 7x, a negative 28z is equal to a negative 91. Our x's have canceled. I now have a negative 18z is equal to a negative 72. Divide by negative 18, and z is equal to a positive 4. Alright, so now that we have z is equal to 4, I go back to the system that we just solved from that had the x's and the z's, and I'm going to choose one of those equations. I'm going to choose the simpler one, so I've got a negative x minus 4z is equal to a negative 13, and we use that z value that we just found, so negative x minus 4 times 4 equals a negative 13, negative x minus 16 equals a negative 13. Move that 16 over, a negative x is equal to a positive 3. Therefore, x is equal to a negative 3. So now I've solved for an x and I've solved for z. The only thing I have left to solve for now is the y. Now, in order to do that, we need to go back to the equation that had 3 variables. And I'm going to choose the one that we solved for, but you can go back and choose any one of the originals. And I'm going to use that one that we wrote twice. We know that our x is a negative 3, which we just found, minus y, which we don't know, plus 3 z's, and z is 4, equals 4. So we've got a negative 6 minus y plus 12 equals 4. Combine like terms. Negative y plus 6 equals 4. Move that 6 over, a negative y is equal to a negative 2. Therefore, our y value is a positive 2. The solution to this system, and we know that it's going to be x comma y comma z, is going to be a negative 3, a positive 2, and a positive 4. Remember when we said we were going to have 2 parts to our test? This is part 1 of your test. So you're going to have to be able to solve one of these systems, and it's a lot of steps, so it's worth a lot of points. So to review, we start with our system. First thing we do is find the easiest one that's going to allow us to eliminate. We write that twice. So we chose this equation, we wrote it 2 times. Then step 2 is we're going to take the 2 equations that we didn't solve for, write them below. Then we are going to eliminate the variable that we chose. We chose y, so we chose to cancel out the y's, which left us with x and z. We eliminated the y's, which left us with x and z. By eliminating one of our 3 variables, we ended up with a system and 2 variables, which is what we're used to. Once we solve that system for one of our variables, make sure that you take this value and you plug it back into one of the equations from the 2 variable system. Once you have 2 variables, then you go back to the 3 variable system from the very beginning to solve for your 3rd variable. Alright, we are not done. We're going to do a couple more of these. So when we look at our next problem, we've got x, y, and z in the first equation, and all of those are easy to cancel out. So I'm going to choose this one to write twice. And then we're going to write the other equations below it. So we've got a 3x, a 3y, a 3z is equal to 14. We've got x minus 2y plus z is equal to 4. Now, you have to choose one variable, because remember, you want to eliminate the same variable each time. So I'm just going to choose the x. So if I want to cancel out the x's, I'm going to multiply the entire first row by a negative 3. That gives us a negative 3x, a negative 3y, a negative 3z is equal to a negative 6. We did not change that second equation, so it stays 3x, 3y, 3z equals 14. We were able to cancel out our x's. Negative 3, positive 3, our y's end up canceling. Our z's end up canceling. That means we don't have anything left on the left-hand side. On the right-hand side, a negative 6 and a positive 14. That leaves us with a positive 8. 0 does not equal 8. Hopefully you remember that if a system, when all of the variables cancel, if you have a false statement left, that means that there is no solution. If the variables cancel and there's a false statement, there's no solution. There's no solution that's going to allow you to solve that system in 3 variables. Next one, we look at our system, and I'm going to choose z as my variable. It's a positive z, so I'm going to use that equation 2 times. I'm going to write that down, get our setup. And then once we have that, we're going to write our other 2 equations. So we've got 3x minus 3y minus z is equal to 2. And then our other equation that we have there is 5x minus y minus z is equal to 8. Going back to our first one, our z's actually already cancel. We've got a positive z and we've got a negative z, so we don't have to worry about getting those to cancel. And that leaves us with a positive x, a positive y equals 3. We look at our second equation. Again, our z's end up canceling, so that's nice. We don't have to worry about making our variables eliminate. They do already. That gives us a positive 3x, a positive 3y, and a positive 9. Now that I have my 2 equations, now with 2 variables instead of 3, I'm going to rewrite that system. I'm going to put those 2 equations together. When I look here, I'm going to choose to eliminate the x's. If I want to eliminate the x's, I'm going to multiply the top row by a negative 3. So I've got a negative 3x, a negative 3y, oops, that should be an equal sign, equals a negative 9. We did not change the second equation. 3 minus 3, gone. Negative 3, positive 3, gone. So I have nothing left on the right, on the left. A negative 9 and a positive 9 ends up being 0. So this time we ended up with the same kind of problem. Our variables ended up canceling. I don't know what x equals, I don't know what y equals, because there's no variable to actually solve for. This time I have 0 equals 0. Well, that is a true statement, and hopefully you remember that if your variables cancel and you have a true statement, that means that you have infinite solutions, or all real numbers, same thing. So everything that you plug in is going to be true. No matter what x, y, z value you plug in, it's always going to be true. Okay, so that is solving algebraically for a system of equations in 3 variables. I would suggest using elimination, but you could use substitution if you would like. Just make sure that you follow those 3 steps each time and you do things in the correct order. Since there's so much work here, it's extremely important that you make sure that when you're doing this, you have your work organized so that I can follow what you're doing. All right, you are all done.